Hello everyone, welcome back to my channel. Today let's solve Leetcode problem 1508 range sum of sorted subarray sums. Okay, so the problem statement states we have been given an array nums, okay, and it contains only positive elements in it. Okay, we have to generate all possible subarrays, and once we have been generated the subarrays, we have to calculate the sum of each subarray. Okay, sum of this subarray is 4, sum of this subarray is 4 plus 2, so on and so forth. Once we generate all possible subarrays and there's corresponding sums, the sums we have to sort it in a ascending order, and we have been given a range left and right, and we have to assume that the array is one based indexing, and we have to calculate the sum of this particular range in the sorted sums array. Okay, so if you sort this sums and if you take the first 5 elements, since it is 1 to 5, so this is the elements which we have to consider and we have to do the sum. Okay, the sum will turn out to be 14. Okay, that is what we are supposed to return. How can we do this problem? The brute force approach is to generate all possible subarrays, okay, and calculate their sums and store it in an array. What have been stated in the problem, we have to just replicate it, and then for the given range we have to calculate the sum. So this way the generating subarrays would take a time complexity of order of n square, and since we are storing all the elements in an array and then we are sorting it, for sorting, since the number of elements would be n square, order of n square, so sorting these elements would also take order of n square log of n square, which is order of n square log n in short. So is there any better way to solve it? Okay, let's first look at the brute force solution, right? So as I mentioned, we will be having an array called sums, where I will be basically storing all the elements, all the subarrays sum. Okay, so I will start at index I equal to 0 and go all the way till the end, and I will also have a j pointer which will start at the ith pointer and go till the end. Okay, so sum would be for each subarray, initially it will be sum will be 0, and then I will keep on adding each element to the sum, which will give me the subarray sums, and then I will be populating into the adding into the sums, and then as in the problem stated, we have to sort the array, and once we have sorted, we have to get the sums in the given range. Okay, so since it was one based index in the problem, in the array we will be having 0 based index, so we will be taking the elements from left minus 1 all the way till right minus 1, and then we will be adding it into our result. Since the answer could be huge, we are doing the modulo and then returning it. Okay, this is just a brute force. Okay, so initially the sum would be equal to 4, sum is 0, and then we will be adding 4, which will give me the subarray starting at 0 and ending at 0. Next, I already have a sum 4, then I will be adding the next element to it, which will give sum from 0 to 1. Since I already have sum, I will just add one more element to it. So that is the intuition. Okay, now is there anything better we can do? Okay, if you closely observe the way the sum is getting generated in the brute force itself, we have 4, which is sum of this is the sum of a subarray which is starting at 0 ending at 0. Okay, all I have to do, if I just add the next element to the previous sum, that would give me the sum of a subarray starting at 0 and ending at 1. Since I know the subarray sum starting at 0 till end, in order to generate this subarray sum, all I have to do is to add the next element to 2. The next element to 2 is basically 3. That is what I have to add. Okay, so the intuition is to just add the element next to the current element next to the sum which was already formed. Okay, this sum was formed for an array which is starting at 0 till 1. In order to generate a new subarray, which ends at 2, all I have to do is to add the next element of this. Okay, so we will be maintaining a priority queue where we will be where initially we will be populating with the base elements, okay, which is like some starting at 0 ending at 0, some starting at 1 ending at 1, some starting at 2 ending at 2, some starting at 3 ending at 3. Okay, the idea is to generate the sums in a sorted manner. Okay, that is the main idea. Okay, how do I generate it? So first I will add all the elements into the priority queue and get the least element. Okay, since 1 is the sum starting at 0 ending starting at 3 ending at 3, in order to get the next element, what I will do, I will take this element and then add the next element to 3 and push it back into my priority queue, and again I will take the next least element. Okay, once I got the sum, I will just take where it is ending it, and then I will add the next element corresponding to the ending sum, and then I will push back into the priority queue. That means I will add 2 plus 3 and again I will push back into the priority queue. Okay, so initially my priority queue contains 1, 2, 3 and 4. Since I've taken out 1, I won't be pushing any element because after 3 there are no more elements, so I won't push anything. Next least element is 2. I will take 2 and then that will be part of my answer. And what is the next sum possible after this? Okay, which is 2 plus the next element to 2 is basically 3. I will add 3 to it, and then I will push back 3 back to my priority queue. Okay, and I will again I will take the priority element and then keep on repeating the same process, but idea is to get the sum of a given range, right? So I will start at 0 and go all the way till the right minus 1. Okay, the moment I encountered a counter of left, from there onwards till right, I will basically add it to my result. Okay, so let me show you here. So as I mentioned, I just created a class called pair which has sum so far and the index at which it is actually ending. Okay, this is the sum which is the sum of a subarray which is ending at 0, starting at 0. Sum ending at 1, we don't care about the start index because all we have to do for the given sum, all we have to do is to add the next element to it. Okay, if you know the end index, we have to just add the next element to it, so in order to get the new sum. Okay, if you know the existing sum, all we have to do is to add the next element to the previous sum's ending element. Okay, so sum and the index. So we have just defined a priority queue which is sorting based on the sum. Okay, and I am populating the priority queue with all the initial elements like some starting at 0 ending at 0, some starting at 1 ending at 1, some starting at 3 ending at 3, some starting at 4 ending at 4, and then I will start from 0 and go all the way till right minus 1, and each time I will be pulling one element from the priority queue which will be the minimum sum at that particular point of time. And if the current index, if it is greater than or equal to left minus 1, that means the range which we are actually looking at, we found an element within the given that range. So the sum which we actually pull in from the priority queue, that will be adding it to the result. There is a possibility that this sum can actually exceed, so we are doing the modulo operation and then updating the result. We should also add the elements back into the priority queue, right? So we will be adding back into the priority queue when the next element to the let's say this is the current sum which we have pulled. Okay, if there is no next element corresponding to this particular index, that means if we reach out of the bound, that means we should not add it. If we are within the bound, then we should add the new pair back into the priority queue. So the new pair would be actually the previous sum plus the next element to it. Okay, this is the previous sum, and the next element to it, next element to 2 is basically the 1, third index, which is 1. So I will be adding 1 and adding this entire sum back into my priority queue, and this new sum is actually ending at index of previous pairs index plus 1, right? I am adding back into the priority queue, and then my result would be, you know, the sum of sum in the given range. Okay, so let me submit this problem. As you can see, this is pretty efficient solution. Okay, so let's, in terms of time complexity, there won't be any much gain over here, but in terms of memory, okay, so we are only processing the n elements. Okay, so yeah, and in the periodic also we will be only having the n elements in the, at max we will be pushing n elements in the periodic queue. So space complexity here would be order of n, and the time complexity is basically the same time complexity. So yeah, that's all about this problem statement. Do subscribe to my coding channel, more such coding videos. Thank you.